A very good morning to all of you. Now today we are going to study the trigonometric ratios of the different angles. In trigonometry we generally deals with not all the angles of trigonometric ratios, but few angles which we generally study in trigonometries are 0 degree, then we have got 30 degree angle, then 45, then we have 60 degree angle and 90 degree angle. These angles are mainly used in trigonometrical calculations and solving trigonometrical identities and so on. Otherwise we can find out the trigonometric ratios of any angle. There is no foundation of such that we are only talking about these, so we cannot find out the trigonometric ratios of the other angle. Now talking about trigonometric ratios of the angle, what exactly does it mean? I am asking you, what exactly does it mean when I say trigonometric ratios of angle 60 degree? Here I have written few angles also, 0, 31. So what exactly means when we talk about trigonometric ratios of the angle? In fact, we shouldn't say the trigonometric ratios of the angle, but we should more clear, if you want to make it clear, then we should say the trigonometric ratios of the sides of the triangle, of a right angle triangle which has 60 degree angle in it. This is what exactly means when we say the trigonometric ratios of 60 degree, when we say trigonometric ratios of 30 degree, when we say trigonometric ratios of 45 degree, 0 degree, 90 degree, because as such we are not finding the ratios of the angles. So trigonometric ratios of 60 degree means trigonometric ratios of the different sides of a right angle triangle, that is perpendicular, base and hypotenuse, which has 60 degree angle in it, right, which has 60 degree angle in it. Suppose if we are talking about, this is the right angle triangle and it has got 60 degree angle. So T ratios of 60 degree means T ratios of 60 degree means what? T ratios of 60 degree means this 60 degree angle, these two lines are subtending the angle, these two lines are making the angle. So the 60 degree angle, the lines which makes the angle 60 degree in a triangle, so what are the ratios of the different sides of the triangle when the angle we are taking as 60 degree? Last class also I told you that this theta, if you take 60 degree, then we are bound to take perpendicular in front of the angle, base adjacent to the angle, and hypotenuse is no doubt hypotenuse. So when we say 60 degree means we are bound to take the perpendicular as assigned by the angle in front of the angle 60 degree, that is perpendicular. So now talking about this, so this is the trigonometric ratios, means 60 degree angle, and in 60 degree inclination the two lines which we are seeing here, they are inclined at a particular angle, that is 60 degree. They are open at that 60 degree angle size. So now this is same whether you make a triangle small or whether you are making a triangle big. This 60 degree angle which is subtended is same. It doesn't means that in a bigger triangle we have got 60 degree angle bigger, or in a smaller triangle we have got 60 degree angle smaller. In all the triangles the angle is same. I mean to say the opening with the opening of the line segment at the tip is the same, 60 degree. So what? So this only it exactly means ki when a triangle has got 60 degree angle, right angle triangle, then finding the different ratios of sine, cos, tan with the angle 60 degree, this is the trigonometric ratios. This is called trigonometric ratios of 60 degree. Or if we talk about 30 degree, then 30 degree also means that the angle which 30 degree is there in the right angle triangle and the ratios of the perpendicular, hypotenuse and the base. So this is the T ratios of the different angles of the triangle. Now here we are going to talk about today the T ratios of 60 degree angle. We are going to see every angle T ratios are fixed. Now we will talk about that, why it is fixed. Sine of 60 degrees is fixed, sine 60 degrees, sine 30 degrees, sine 0 degree. In fact, what I would like to tell you is that the trigonometric ratios of all these angles are constant. There is no change in the trigonometric ratios. Means sine 60 will have a the constant ratio, sine 45 will have the constant value. Why do we get the constant value? Because and what are the different values of sine 60, 45, different angles, we will see. So here today we are going to calculate the T ratios for 60 degree angle. Now calculating T ratios for 60 degree angle means in a right angle triangle we are going to find out the different trigonometric ratios values when the angle is 60 degree. Now for this, what we have taken here, we have taken a triangle ABC, triangle ABC, equilateral triangle, equilateral triangle. So since it is equilateral triangle, then we are taking all the sides to be same. 2A we are taking sides, we can take sides as A also, but for making it convenient for our calculation, because this perpendicular divides the sides into two equal parts, so we can easily write here the two different parts as A and A, and our calculation can be a bit easy. Otherwise you are free to take A also. We can take A also, then it will become A by 2. So we are what we are doing here, we are finding the trigonometric ratios of 60 degree angle. We have taken equilateral triangle and draw one perpendicular from A on the side BC. Let this AM is perpendicular to BC. AM is perpendicular to BC. Now when AM is perpendicular to BC, then what do we see here? We can see triangle ABM, we can see triangle ABM and triangle AMC. They both are congruent triangle. They becomes congruent because this is common side, this is 90 degree. Then the RHS property, both the triangles are congruent, right? Now why we are proving it congruent? Because we need to find out this side. So if the triangles are congruent, then it is very clear that these two sides, that is BM, will also be equals to MC, because they are the congruent part of a equal parts of the CPCT, congruent part of the congruent triangle, we can say corresponding parts of the congruent triangle. So that is BM equals to MC. So we can write this as A and this also as A. Now see, in triangle ABM, this side is given 2A, this we have got A. By proving it both the triangles congruent, so we have proved that this is a two sides are equal. So this is A. We need to find out AM. So AM we can write here, this is a right angle triangle, so this BM that is bm square plus am square equals to ab square right. So we need to find out this am square, so we can also write here am whole square equals to ab square minus bm square, and that will be equal to ab square is how much, 4a square minus a square, that is equals to 3a square, or we can say here am equals to root under 3a square, that can be written as a root 3. Okay, so don't need to be very much calculative here. What we have done here, we have just found the value of this a root 3 by Pythagoras theorem. We have found the values of am, that is am square plus bm square equals to ab square. Therefore am square equals to 2a square, that is 4a square minus a square equals to 3a square. Then after that the simple calculation, and am equals to a root 3. Now we will find out the values. Now just have a look to this triangle abm. We are looking to this triangle only, abm. So in this triangle abm, so this is, we are taking angle 60 degrees, so the side opposite to 60 degree will be perpendicular, so this is perpendicular, this is hypotenuse, and this is base, right. Now what will be the sign in triangle abm? Which triangle we are talking? abm. We are talking abm. Sine 60 degree equals to what is perpendicular by sine is perpendicular by hypotenuse. Perpendicular is how much we have calculated here, a root 3. A root 3 upon hypotenuse is 2a, right. Now there is no need to explain you why we are taking, because this is perpendicular. This is perpendicular because whichever angle you are taking, the side just opposite to that angle is considered to be perpendicular, and the side adjacent to that angle is considered to be base. So here what we have taken, perpendicular by hypotenuse, perpendicular value is a root 3 and hypotenuse value is 2a. Or we can write here also the values. See, I am writing here perpendicular is how much, a root 3, hypotenuse is 2a, and base is a, right. So after calculating, what you are going to get here, this a got cancelled, we got here root 3 upon 2. Now cos 60, we are finding here cos 60 degree. Cos 60 is what? Base upon hypotenuse. What is base here? A. Hypotenuse is 2a. How much you will get? A and a got cancelled, 1 by 2, right. Sine cos. Then the next is tan 60 degree. Tan 60 degree. This is perpendicular by base. What is the perpendicular here? A root 3. Base is how much? A. That comes out to be a and a got cancelled, so that will be root 3. So these are the trigonometric ratios for the angle 60 degree, that is sine, cos and tan. tan. So when we say sine 60 degree means what? Root 3 by 2 means we have divided perpendicular and hypotenuse, then we got the value root 3 by 2 cos 60. When we divided the base and the hypotenuse, we got 1 by 2, and tan 60 perpendicular by base, we got root 3. So these are the different trigonometric ratios for the angle 60 degree. Now we can also find out sine is 60 degree, then cosec. What is cosec here? Cosec is how much? Cosec is just opposite of sine, that is 2 by root 3. Sec will be, sec is how much? 2 by 1, that is equal to 2. Then tan is, tan becomes cot. Cot is how much? 1 upon root 3. Right? Because you know sine 60, then cosec, I have told you sine is perpendicular by hypotenuse, then the cosec is hypotenuse by perpendicular. So sine is perpendicular by hypotenuse, then it is hypotenuse by perpendicular. Cos is base by hypotenuse, then hypotenuse on the top by base. Tan 60 is perpendicular by base. Here 1 is not here, we can write here as a 1, perpendicular by base. Then it is cot is opposite, means base by perpendicular. So these are the different trigonometric ratios for the angle 60 degree, and always keep in mind these values which we have got. So what practically it means? When I say sine 60 degree is here root 3 by 2, means sine 60 degree values when I divide perpendicular, means it practically it means what? When the angle is 60 degree in a right angle triangle and we divide perpendicular and hypotenuse, then the perpendicular and hypotenuse ratio or the values will always be root 3 by 2, will always be root 3 by 2. It is not going to change. Cos, it will always be 1 by 2. Tan, it will always be root 3. Now this value is constant. Now have you ever thought one thing? Okay, we have calculated, we have seen, but doesn't it makes you a little uneasy that the triangle which we are talking, the triangle 60 degree angle triangle can be a very small triangle also. 60 degree triangle can be a very big triangle also. It can be a very enlarged giant kind of a triangle also. So how is it possible that this perpendicular and hypotenuse ratio will always be same? Because the sizes are different. So it may be that the size, since the size of the sides of the triangle are different due to the different sizes of the triangle, so it may also be different. So why it is constant only? What is the proof that the different trigonometrical ratios for 60 degree is same only, that is it is a constant and the fixed number which we have calculated here? Now see, later on in the chapter we are going to find out the values of the height of the mountains, height of the trees, height of the tower, and in that case also what we do, we are imagining a very big triangle. To calculate the height and the base, we are imagining a very big triangle in the air, and that is the tip of the mountain. We are seeing it makes an angle of elevation. These questions we are going to do. So in solving such kind of a question also, we are using these important values which we have got here, and with the help of these values only we are calculating there the height of the tower, the depth, the altitude of different heavenly bodies, or those things which we are unable to calculate manually. Those things we are calculating with the help of this trigonometry. Now see, in case of we will talk about one case, like just to make it clear, one thing I would like to tell you. Now see, why do we say the angles are always the ratios are always same? Suppose we are taking here one right angle triangle, and suppose this angle is 60 degree, right? The angle is 60 degree, and we have found different trigonometrical ratios. This is perpendicular, sides opposite to the angle. This is hypotenuse. Hypotenuse doesn't have any problem, it is always fixed. This is base. So this, now what it says ki T ratios for 60 degree will always, so if I extend this line also I extend, so what am I doing here? Now suppose this is A, B, C, M, N, P, Q, R, S. Now why I have drawn this 60 degree angled triangle, that is a 90 degree angle in which we are talking about 60 degree angle. Why we are why I have drawn this this figure? Why I have drawn? To make you understand that the ratios of the different sides of the right angled triangle, when the angle is 60 degree, will always be same whether the triangles are big or small. Now if you see this figure, then we can see this is a triangle ACB. Now it is extended and it is made MCN, right? So this is also perpendicular for this triangle, and this is base for this triangle, and this is hypotenuse for this triangle, right? This is hypotenuse for this triangle. Now it means ki this perpendicular by hypotenuse and this perpendicular by hypotenuse both should be same. Means that is the perpendicular by hypotenuse, blue colored perpendicular by hypotenuse, should be equal to red color perpendicular by hypotenuse, right? These two should be equal. Now what is the proof? What is the proof that we can say that both the ratios are equal? Now if you see these two triangles, then we can see these angles are equal, and the third angle is also equal. So you can see triangle ACN, this is bigger triangle and this is smaller triangle, are similar triangle, right? Similar triangle means what? Ki ratios of the if the two triangles are similar, then we know that the corresponding ratios of the similar triangles are also same. Corresponding ratios of the similar triangle, corresponding ratios of the sides of the corresponding sides of the similar triangles are also equal. This we have studied in the similarity of a triangle. Means if you see here, then what do we see in triangle bigger and smaller triangle, triangle MCN? If you see it in triangle MCN and triangle MCN, triangle ACB, what is happening here? Both the triangles are similar, right? Triangles are similar because all the angles are same. These angles are equal. Why we say these angles are equal? These angles are corresponding angle. This is 90 degree, this is 90 degree, and I have extended. Why I have extended this line? So this is a parallel line. Okay, I have extended, this is a parallel line. This is 90 degree angle, this is 60 degree angle. Then automatically this also becomes the same angle. So all the angles are equal, so the triangles are similar. So corresponding sides. Now if we corresponding sides we will take here, say AC upon AM. AC side, this hypotenuse of this smaller triangle divided by the hypotenuse of the bigger triangle CM equals to perpendicular of a smaller triangle. Perpendicular of a smaller triangle is AB. AB divided by perpendicular of bigger triangle, that is MN. Right? What we are exactly, don't get confused, what we are exactly doing here. We said if the angle is 60 degree, then the trigonometric ratios for 60 degree angle will always be same whether the triangles are small or big, and the values we have calculated here, and we say that the values will always be the same value. Values will always be same whether the triangles are big or small. So that's what only we are trying to see. If we are making two different bigger triangles, one is small and the other is big, then we are checking whether the ratios of the sine, cos and the tan, they are equal or not. So here what we have done, we have made extended the hypotenuse and the base, and we have made the another triangle MCN, and this triangle is similar to the earlier triangle, smaller triangle, and this is applicable for the other triangles also, the bigger triangles which are made. Similarly, they can also be proved. So we have proved that both the triangles are similar. This angle is common, this is 90 degree, this is also 90 degrees, so third angle is also equal. So both, all the three angles of these two triangles are same, therefore the two triangles are similar. And now since both the triangles are similar, so we are taking the corresponding sides to be equal. Now what corresponding sides we are taking here? We are taking the corresponding sides of a smaller, that is the hypotenuse of a smaller triangle and the hypotenuse of a bigger triangle. What is the hypotenuse of a smaller triangle? AC, and the hypotenuse of a bigger triangle is CM. Now perpendicular of a smaller triangle is AB. This is the perpendicular of a smaller triangle, and the perpendicular of a bigger triangle is MN. Right? Why we are writing this one? Now the question arises, why do we write here? Because the corresponding sides of corresponding sides of similar triangles are equal. Corresponding sides ratio of the similar triangles are equal. So now here AC, what is AC here? AC is red H, we can write hypotenuse with the red ink, and CM is a hypotenuse with the blue ink. Then we have AB. AB is perpendicular here, and MN is perpendicular with the blue. Now see, from this what we are seeing here, if you cross multiply, then what will happen here? We can write here, this H will come here. We can also write this as H by P equals to, this will go here, this goes here, red ink, H by P, and this H by P. Why it happens like this? Now see, if I multiply this H here, and this will come down to here, P will come down here, and this H is going to multiply here. So we will get here H upon P, and then here it is multiplied H upon P. So this again can be written as P upon H and P upon H. this only. So what we saw, what is P upon H? P upon H is sine theta, means this blue line, blue colored P upon H is for smaller sine theta of a smaller triangle, and a red colored P upon H is the sine theta of a, okay, this is for the blue colored is for the bigger triangle and the red colored is for the smaller triangle. So what we saw ki sine theta of a bigger triangle P by H is equal to sine theta of a smaller triangle. This is P by H is perpendicular sine theta, that is perpendicular upon hypotenuse. So what we are getting here, perpendicular upon hypotenuse of both the triangles are same, bigger triangle and the smaller triangles. In both the triangles we are seeing here sine theta are same. P by H is sine theta of a bigger triangle, and P by this red P by H is sine theta of a smaller triangle. So we have proved that if the angle is 60 degree, then whatever size of a triangle which is made with this angle 60 degree will have the same values of T ratios, that is sin 60, cos 60 and tan 60 will have the same value. With the change in the size of the triangle, there is no change in the values of the T ratios. Now next class we are going to discuss about the T ratios for 30 degree angle, then we will find about the 0 degree, then 90 degree and 45 degree. Just have a look, and if you have got any doubt you can ask me. Thank you.